Hey everyone, in this video we're going to be talking a little bit more about half equations, specifically how to write them in acidic conditions. We're going to be going over a couple of things, notably number one, where we can find half equations and what to do if we can't find them. Following on from that, we're going to be talking about the steps for writing our own half equations, and then we'll do a few examples for acidic conditions. So, let's get started and explain what we're going to be going over. So, writing half equations. As I said in the previous video, redox reactions are comprised of a reduction component and an oxidation component. And the two acronyms that I wanted you guys to memorize were oil, rig. Oxidation is loss and reduction is gain of electrons. Now, today we're going to be looking into a bit more detail about what half equations actually are. So, half equations are the two components that make up a full redox equation. They can be reduction or they can be oxidation equations. Now, whenever you're answering VCAR questions for redox, you might be able to find half equations in the electrochemical series in your data book. So the electrochemical series looks like this. It's table number 2 on page 4, and each of these lines is an individual half equation. We'll be going over this in a little bit more detail in later areas, but for now just know that everything listed here is a half equation. Now back to our notes. However, what happens is that sometimes in our questions we'll be given elements or compounds that can't be found in the electrochemical series. And when they can't be found in our data book, we're going to have to write these half equations ourselves using a number of steps. So, today we're going to be looking at these important steps. Let's go with step number 1 and work our way through. So the first thing we need to do is balance the molecule, which means we need to balance everything except for oxygen and hydrogen. So what does this mean? When we're given a redox scenario in a VCAR question, they will usually give us a transition. So they will say that in our redox equation, something happens that turns something such as Cr2O72- into Cr3+. And they'll give us these two elements. And what we need to do is construct a redox half equation, so either reduction or oxidation, out of this information. So let's actually use this example here throughout our steps. So we're converting Cr2O72- into Cr3+. That's what we've been asked to do. So step 1 is to balance the molecules, everything except for oxygen and hydrogen. Looking at the compounds we've been given, the only exception to oxygen and hydrogen here is our chromium, our Cr2 on the left and our Cr3+ on the right. So the first thing we need to do is pretty much balance this all out. So all we're going to do is balance it like a regular equation. Look at the left and right, and it seems like we need to add a 2 over here to get two chromiums on each side of our reaction, of our half equation. So now let's move on to step 2. Step 2 is to balance oxygen by adding H2Os. So all we need to do here is to balance any remaining oxygen. So let's look at our equation so far. Cr2O72- 2Cr3+. So as you can see, we've balanced our Crs. However, we do have our oxygens left over. So now we need to balance our oxygens. As you can see on the left-hand side, there are 7 oxygens. So the way we balance this out is by adding, 7H2O to the right-hand side. And as you can see, by doing that, we've balanced out our 7 oxygens. Moving on to step 3. Balance the hydrogen by adding H plus. So now we've got Cr2072 minus going to 2Cr3 plus 7H2O. As you can see, we've balanced our oxygens. Now we just have our hydrogens left. So we need to balance these on the left-hand side now, and the way we do that is by adding H plus. On the right-hand side, it seems like we have 14 hydrogens, so we're going to add 14 H plus to the left, and now we've balanced that out. And now for our very final step. Balance the charges by adding electrons, which are E minus. So as you can see in our equation, we have a few pluses and minuses floating around. So what we need to do is balance these charges. What we can do is count up the charges on each side and kind of try and equate them. On the left-hand side, we've got charges of plus 14 over here because we've got 14 hydrogens, and we've also got a minus 2 because of the Cr2072 minus. On the right-hand side, we have a plus 6 because of 2Cr3 plus. So if we take a look at the charges on both sides, we can see that we've got a positive 12 on this side and a positive 6 on this side. So we're going to have to balance these out by adding E minus. Now, as you can see, E minus is obviously a charge of -1. So what we need to do is add E minus to our left-hand side, and we'll be adding 6. Because once we add 6 E minuses, we're going to be pretty much going 12 minus 6 equals positive 6, and positive 6 and positive 6 are equivalent. Thus, we've balanced our charges on both sides, and that is going to be our final half equation. 6E minus plus 14H plus Cr2072 minus gives us 2Cr3 plus 7H2O. And that is our final half equation. So now let's do a couple of quick examples and finish off this component. So let's start off with a nice and easy one. Example 1. We're going to do Cu2 plus and convert it to Cu. So in this case, we've got Cu2 plus to Cu. Step number 1 is to balance everything except oxygen and hydrogen. Looks like that's already done for us. Step number 2 is to balance the oxygens. There aren't any. Step number 3 is to balance our hydrogens, and once again there aren't any. So we can pretty much skip straight to number 4, which is balance our charges by adding E minus. The right hand side is a charge of 0 and the left hand side has a charge of positive 2. So what we're going to do is add 2E minus to our left hand side, and that's going to balance everything out 0, 0. Nice and straightforward. That's example 1. Let's take a look at example 2 and kick things up a notch. We're looking at PbO, so lead oxide, to Pb. Step number 1, as always, is to balance everything that isn't oxygen and hydrogen. Seems like our lead, our Pb's are already balanced, so now let's balance our oxygens. We've got PbO going to Pb plus H2O. So now we've done that, let's balance our hydrogens. Let's add 2H plus on the left-hand side. And finally, to balance our charges, we're going to have to add 2E minus to our left-hand side. And that is going to be our final equation. One thing you guys might notice I haven't been doing throughout this section is adding states. So now that we've got hopefully a bit of a good understanding of what's actually going on, let's just add in some states. So for our example 1, we're going to go with solid and aqueous. And remember, never to write any states next to our electrons. They aren't solids, liquids, or gases, so just leave them empty. Now for this question, we're going to add, for example 2, we'll add our states again. We're going to go with liquid here, and we're going to say Pb is, let's say it's a solid. Our lead oxide, let's say it's a solid once again. We'll add an aqueous here, and that's it. So in general, usually our H pluses are aqueous and our H2Os are liquids. Now let's work on example 3. Here we've got Mn 2 plus being converted to MnO4 minus. So here we're going to have Mn2 plus Mn2 plus being converted to MnO4 minus. Step number 1 is to balance our Mn's, and as you can see, we don't really need to do that. Next step is to balance our oxygens. So we've got 4 oxygens on the right hand side. We'll add 4 on the left hand side via H2O liquid. And then we're going to have to balance our hydrogens. So we'll have to add 8H plus on this side. And finally, we'll balance our charges. We've got a positive 2 on the left hand side, and it looks like we've got a positive 7 on the right hand side. So we'll add a total of 5E minus on this side. And that is going to be our half equation for this case once again. So just to recap, we've gone over a couple of things, notably half equations and what they are. And we've gone over the steps for how to write our own half equations if they aren't given to us in the data book. So we've learned the 4 main steps that we have to work through systematically one by one. And then we've just done a couple of examples to make sure that we have a good understanding of how each of these works.